So today we are going to discuss about the quantum mechanical model of atom. This is the last model we are going to discuss, okay, and the final one, okay. After discussing every model and then finding the drawbacks, okay, so every model, okay, we have discussed, okay, have drawbacks, limitations, okay, and after that new models comes, okay, after that another models comes, and still there is limitations, okay. So those are for our understanding, okay. So we cannot directly just come here, okay, to this model, okay. So those model will give us how the structure of the atom, okay, idea of the structure of atom. So finally we come back to this quantum mechanical model of atom, okay. So we have discussed about Moore's model, Rutherford model, okay. So those models talks about the particle-like nature of electron. So the main drawbacks, okay, for those models were that they consider it to be a particle-like, okay. The wave-like character was not considered, okay. So electron also behave as a wave and as a particle, okay. And then this classical mechanics also, okay, based on Newton's law, okay, also consider that motion of object, okay, is considered to be like a particle, okay, in classical mechanics also, okay. That classical mechanic is applicable for large object, okay. However, for microscopic object or minute object, okay, that classical mechanic, okay, does not hold, because electrons, okay, for small or subatomic particles, okay, subatomic particles means minute particle or micro particles like electrons, okay, you could not explain the motion of minute particles, okay, classical mechanics. And then these subatomic particles, they have wave-like character also, okay, particle and wave-like character, okay. So before coming to this one, okay, in the previous video we have discussed about the de Broglie and Heisenberg uncertainty, okay, de Broglie wavelength, Heisenberg uncertainty principle, okay. So those two gave, okay, de Broglie and uncertainty, okay, propose, okay, that electrons, okay, have wave-like character also, or they gave, or they talk about the dual nature of particle or matter, okay. So after this, the dual nature of matter, okay, what will come is a quantum mechanical model of atom. So in this quantum mechanical model of atom, okay, so in this quantum mechanical model of atom, before going, let us see a small definition, okay. Branch of science. So quantum mechanics, okay. So quantum mechanics is a branch of science, okay, that takes into account the dual behavior of matter, okay, that is the wave-like character and particle-like character of subatomic particles, okay, like electrons, protons, neutrons and all, okay. So those are the subatomic particles, okay. So this branch of science deals with the study of dual behavior, okay, of matter, okay. So this branch of science, okay, deal with the theoretical science, okay, that deals with the study of motion, okay, motion of microscopic object. Microscopic object or matter, we can say, okay. So motion of microscopic object which involves the behavior, that is wave like and particle like properties, okay. So you might have this term, okay, quantum mechanics, in that movie also, Ant-Man, okay. So I don't know how they have not discussed about the detail, okay, about their scientific technology, but in that movie, okay, the scientists, okay, use the word quantum mechanics, okay, lots of time, okay. If you watch that, you will come across quantum mechanics. So let's come back here. So this quantum mechanics, okay, was developed by Werner Heisenberg and Erwin Schrödinger. Okay, so Schrödinger, he gave a equation, okay, of wave function, okay. So for a system such as an atom, okay, so or a molecule, whose energy does not change with time. The Schrödinger equation is so Schrödinger, he gave a famous equation, okay, of wave functions, okay. So h cap, this is xi, okay, is equal to E xi. So this h cap, okay, yeah, this is a mathematical operator, known as Hamiltonian, okay, or Hamiltonian operator. Xi, okay, here is the wave function. E is the total energy, okay. So this total energy, okay, total energy of the system. So this total energy includes the kinetic energy, okay, of the subatomic particles, attractive, okay, potential energy, okay, between the electrons and the nuclei, okay, or repulsive potential energy, okay. So this is the total energy of the system. So this equation, okay, is a solution, okay, of the wave function, okay. So in order to calculate this one, okay, we're not going to calculate how this value or these solutions came, okay. We're not going to calculate, okay. We're just giving the relation, okay, the equation, okay. So you might study this one, okay, in your higher class. So this wave function, okay, this wave function give the location or probability of finding the electron, okay, in the atom, okay, or around the nucleus, okay. So this xi will give the probability of finding the electron in the 3D dimensional, okay, 3D space or dimension, okay. So the electron can be anywhere around the nucleus, okay. So this xi will give the probability, okay, probability. okay, around the nucleus. Okay, however, the exact position cannot be determined. Okay, if we can exactly determine the position or even the velocity, then Heisenberg uncertainty will not hold. Okay, so xi square, okay, xi square, okay, gives the probability of finding electron at a point written in short form, okay, within an atom. So this xi square, okay, if you calculate this xi square will give the probability of finding the electron at a point. Okay, now the mathematical calculation we are not going to solve here. Okay, you might solve in your higher class. Okay, so for now leave it as it is. Okay, so this xi square will give the probability of finding the electron, and this xi square is proportional. Okay, is proportional to the probability of finding the electron also. Okay, so we have talked about the three dimensional. Okay, so in three dimensional there will be x-axis, y-axis, z-axis. Okay, 1 2 3, okay, three dimensionals. So in this axis electron can be anywhere. Okay, probability of finding the electron can be anywhere. Okay, and that xi square will give the probability. Okay, so for now we are not going to discuss about the xi square. Okay, so this quantum mechanics, okay, model give three variables. Okay, since there are three axes. Okay, so three variables. Okay, so this quantum mechanics talks about set of three variables. Okay, and these three variables will give the probability of finding the electron. So these three variables, okay, are n, l, m. Okay, so we are going to talk about n, l, m. So what is this n, what is this l, what is this m? So n is the principal quantum number, l azimuthal quantum number, and magnetic quantum number. After these three, one more is there. Okay, one more quantum numbers. Okay, so these are called quantum numbers. So one more is there. Okay, oh, in your textbook this magnetic is also denoted by ml. Okay, ml, and then ms. This is electron spin quantum number. Okay, so there are four. Okay, firstly is this it has been given in your textbook, the three quantum number, and then lastly the fourth one. Okay, in your textbook, but we are going to discuss all the four. Okay, so these variables, okay, these variables give the position of the electrons, okay, in the three dimensions. Okay, so the probability of finding the electrons in the three dimensions. Okay, or we can say, suppose this is, or this gives the address of the electron. Okay, so this is the state, okay, example Nagaland, and this is the district, okay, Kohima, and house number, okay. So this will give the in which shell, okay, it is present, okay, in which subshell, okay, or in which orbital, okay, the electron is present, okay. So simply remember that concept, okay, and it will give you an easy understanding, okay. State, capital, house number, okay, like that, okay. So if you know the state, then secondly the capital or the city in which you live, okay, and then your house number, okay, like that. So electrons, okay, is found in orbitals, okay. So these orbitals are three-dimensional space, 3D space, okay. So these orbitals are 3D space in which probability of finding electron is maximum, okay. So first we are going to talk about the shell, okay. So in the shell, okay, subshell is present, okay, and then after subshell orbitals is present. So in that orbital electron is present, okay. Please know that shell, after that subshell is present, and after that orbitals, okay, and then electron is present, okay, in that orbitals, okay, in that 3D space. So we'll discuss that.